So recognize functions. A function is a relation in which each element in the domain corresponds to exactly one element in the range. So this would be an example of function. If you have these two sets, this is my domain, this would be my range. From each element from the domain map to only one number into the range. This would be a function. However, this doesn't correspond to be a function. If I can find from my order pair that one number from the domain maps to two different numbers into the range, that means that's not a function. That's violates the definition of the function. And we can easily find that using a vertical test. So if I have a graph, if I draw a vertical line on that graph, if that vertical line intercepts the graph exactly at one point and one point only, then that corresponds to a function. So it looks like all linear functions, all the straight lines are, can I say all straight lines are functions then? Except if the line is vertical, right? Let's remember that. As long as the line is not vertical, all other linear equations are functions because we would pass the vertical test. However, this parabola, however, this ellipse is not a function. The parabola is a function also, right? Because if I draw a vertical line through a parabola and move this line, if I draw a line, vertical line here, and move this line here throughout the graph, it's going to intercept this line at one point and one point only. So that's a function. This is a function, right? However, the ellipse is not a function because if I draw this line here, it would intercept this at more than one point, right? So that violates the vertical test. So let's see what happens when it does do that. So if I fail that vertical test, looks like that I get these 2 points right on top of each other, right there. Right? So let's kind of name this, let's call them, I'm just going to make up some numbers here. I'm assuming that if this is, let's say, 2, we get, I don't know, it's just 3, and this is -2. I'm just making up numbers right now. These are not real points. But looks like these 2 points here, if I write as an ordered pair, they would share the same x. I assume it's 2 now. The number 2 from the domain maps to different numbers in my range. That's what happens when you fail the vertical test. Just like it happened here. See, the number from the domain mapped to different numbers in range. The number from the domain mapping to different numbers on the range. So this is what happens when you fail the vertical test. You see 2 points right on top of each other. So if you have a bunch of ordered pairs and you want to know if those are correspond to a function or not, you just want to check, make sure that the first number on all those sets doesn't repeat. If it doesn't repeat, that most likely it's a function. If it repeats, it's not a function. So let's see. If I have a bunch of ordered pairs here, does this correspond to a function? No, because -1 from the domain maps to different numbers into the range. So that's not, if I would graph these two lines, would be right on top of each other. That would violate the vertical test. How about this one? Is this to correspond to a function? Yes, because the numbers from the domain does not repeat. It does not map to different numbers into range. So this set of numbers corresponds to a function. These set of numbers are not correspond to a function. So look for the first element on the order pairs only. Okay, looking at these two graphs, which one of these are function? Is this a function? No, because same number from the domain maps to different numbers from the range. Fail the vertical test. The vertical line intercepts that graph more than 1 point. Is this a function? This is, remember, it says this is a graph of absolute value. Is this a function? Sure is. Because if I draw a vertical line, the vertical line, if I move that vertical line, it's only going to intercept this at 1 point only. 1 point only throughout the whole graph. Okay? So this is a function. This is not a function. Then a function is evaluated, a value is substituted into the function. So let's say we have a function. If you already know, we already established all the linear equations except the one, a vertical line or function. So this would be an example of that. So if I have y is equal to 3x plus 2, if it is a function, then we can call it, instead of y, we call it f of x. That's a fancy way to write the name. So f of x means we have a function in terms of x. That's all it means. I could call it g of x if I want to, or h of x, doesn't matter. It's just a function. I'm going to call the function something. So what that means is I can evaluate this function for different values now. So it means if somebody come and tell you what is f of 1 is, they're really asking you if y is equal to 3x plus 2, if x is equal to 1, what is y? We did that before when we graphed the line. If x is equal to 1, what is y? We substitute for each x1, and that's how you evaluate y. So it would be 3 plus 2 is equal to 5, right? Same thing here. So with 3, you substitute for each x1, and you get the same result, of course, 5. The nice thing about representing this as a function is now I can find f of anything else I want. I can find not only f of any number, I can find what is f of z is. Can somebody tell me what f of z is? If f of x is equal to 3x plus 2, what is f of z? Very good, that would be 3z plus 2. The nice thing about this again is I can take that x and put anything I want in there. I can put what is f of apple. You put the symbol there. What is that? 3 times this little symbol apple plus 2. I can make a picture, put it there. I can find what is f of x plus 2 is. Now this is expression. What is f of x plus 2 then? 3 times x plus 2 plus 2. So we can simplify that actually. 3x plus 6 plus 2. 3x plus what? 8. So f of x plus 2 is 3x plus 8. So I can find f of anything else I want. So in this case, if f of x equals to minus x squared, what is f of 2? You substitute for each x to, remember, this negative, this minus doesn't belong to that exponent. So you have to be very careful. If I want to find what this f of 0 is, what do? You substitute for each x0. So it would be 0. If I want to know what f of this little girl is, what we do? Just put it in here. So it could be anything. That's the nice thing about function. It should be same girl. Do we get the picture? So if I want to know what f of 2x minus 5 is? What is that? Minus 2x minus 5 squared. Does that make sense? Okay. So find f of 2 for each function. Now, we're going to look at these set of numbers here. F of 2 means when x is equal to 2, what is y? Remember that? F of 2 means, if I had a little chart here, if x equal to 2, what is y? So in my order pair, I want to look for the order pair of which x will be equal to 2. What is it? Right here, the first one, right? Here it says that x equal to 2, y is equal to 6. So there it is. That's what it is. That's what f of 2 is. So that's why f of 2 is equal to 6. By just looking at this order pair. We want to find f of 2 in this graph. So again, remember what f of 2 means. F of 2 means when x is equal to 2, what is y? That's what f of 2 means. Okay, so let's take a look at the graph. When x equal to 2, 2 is right here. What is y? What is it? 1. So on my graph, I can read the order pair. When x equal to 2, looks like y is equal to 1. So that's why f of 2 is equal to 1. That's why looking at the graph, we can find that. Let's find f of minus 2. Okay, remember again, f of minus 2 means if x equals to negative 2, what is y? This is negative 2, y is, looks like is 3. That's my point. This point here is if x equals to negative 2, my graph shows is 3, so that's supposed to be 3. So looking at the graph, you can find these values. What is f of, okay, in this case, for what value of x is f of x equal to 0? So they're switching this now. They're saying that for what x, y would be equal to 0, in other words. That's what they're saying. Okay, so I'm going to look at my y. At what point y is 0? Okay, it looks like y is 0 here. I'm going to move up here, see where my graph is going to hit when y is equal to 0 is right there. So in this case, if x equal to 4, y is equal to 0. So therefore, f of 0 must be equal to 4. So you can go back and forth with this.